going to be looking at another question about sequences and series. So in question 11 we're given that the ratio of the 5th term to the 12th term of a sequence in an arithmetic progression is 6 to 12. If each term of this sequence is positive and the product of the first term and the third term is 32, find the sum of the first 100 terms of the sequence. So typically what we do when we're given a question like this is we want to create a system of equations. So let's see what information we're given first. So we're given that the 5th term, u5 divided by the 12th term, u12, is going to be 6 over 13. And another piece of information we're given is that each term of the sequence is positive, so we're going to use that when making restrictions. And we're also given that the product of the first term and the third term, so let's say u1 times u3, is going to be 32. So typically when making a system of equations, we want to choose a variable to be solved or to be used in the system of equations. So if you have one equation, you can solve for one variable. If you have two equations, you can solve for up to two variables. So let's try to express everything in terms of the first term, u1. So u3 can be written as u1 plus 2d. That comes from the un equals u1 plus n minus 1 times d formula. You should know that by now. And this equals 32. So this is u1 squared plus 2u1d equals 32. Let's isolate for d. So we have d equals 32 minus u1 squared divided by 2u1. So now we have d in terms of u1. So let's see if we can express this ratio in terms of u1 and d. So we know that u3 equals to u1 plus 2d. So we can say u5 equals u1 plus 4d, and u12 equals u1 plus 11d. So let's first cross multiply this. So we have 6 times u1 plus 11d equals 13 times u1 plus 4d. Now let's sub this into this. So we have 6 times u1 plus 11 times this entire thing, so 32 minus u1 squared over 2 times u1. And then we have this entire thing is equal to 13 times u1 plus 4 times this. The 2 will cancel with the 4, so we have 2 times the entire thing, 32 minus u1 squared over u1. Now let's try to simplify this. So we have this equals to this. I'm going to write it in red. Actually, I won't. Let's just try simplifying. So 6 times u1 plus, let's do 11. Pull out my calculator here. 11 times 32. It's 352 minus 11 u1 squared over 2u1. This equals 13 times brackets u1 plus 64 minus 2u1 squared over u1. Now let's try to bring this into this here and u1 into this here. So we have, so we have multiply this term by 2u1, so we have 2u1 squared. Let's simplify right now. So we have 2u1 squared minus 11u1 squared. We have negative 9u1 squared plus 352 over 2u1. And this equals 13 times, this is going to be u1 squared plus 64 minus 2u1 squared, so we're going to have negative u1 squared plus 64 over u1. Now let's see what we can cancel. We can say this is going to be 3 up front, and then we can multiply both sides by u1, cancel this. Now let's see what we can do. We distribute this 3 in, so we have negative 27 u1 squared plus 3 times 352, that's going to be 1056 equals negative 13 u1 squared plus 64 times 13. It's going to be 832, I mean. 832. Now let's bring this over here. I just like it to be positive, so we have 14 u1 squared equals 1056 minus 832. It's going to be 224. Divide by 14 on both sides. We have u1 squared equals 16. And now we have to use the restriction. Each term of the sequence is positive. We know the first term is going to be positive. u1 is the first term, so we have u1 equals plus or minus 4. u1 is greater than 0 according to the restriction, so therefore u1 equals 4. So the reason we're trying to solve for u1 is because we know a formula. We know two formulas that are able to calculate the sum of an arithmetic progression. We have n over 2 times 2 u1 plus n minus 1 times d, and we also have Sn equals n over 2 u1 plus un. We're obviously going to be using the first formula because we're not given the last term of the sequence, and that's going to be difficult to find. And so what we're going to do now is we're going to try to solve for d. There's not much space here, but let's try to make do by erasing some of the stuff we already have. Alright, can I make this eraser bigger? Apparently not, so let's just try to erase some of this. Okay, so in the following step I'm just going to solve for d and then use the equation Sn equals n over 2 u1 plus n minus 1 times d to solve for the sum of the first 100 terms. I'm going to plug in n equals 100 and then just solve that. So the problem is pretty much solved at this point. So we're given that u1 equals 4, so we have d equals 32 minus 4 squared, which is 16. It's going to be 16 on the top, over, I can't even read my own handwriting. What's this say? Over, what is this? Okay, so we had u1 plus 2d equals 32. Squared plus 2 plus 32. Okay, it's a 2. Alright, 2u1, so it's 2 times 4. So this is going to be 16 on the top divided by 8, so it's going to be 2. So we have u1 equals 4, we have d equals 2, and then we have n equals 100. Now we just got to plug it in the equation. S of 100 equals n over 2, so 100 over 2 times 2 times the first plus 100 minus 1 times the d, which is 2, and then we have 58 plus 99 times 2, and this equals, according to my calculator, it's going to be 99 times 2, 1 second, 99 times 2. Okay, so it's 10,300. So you know the sum of the first 100 terms in this arithmetic progression is going to be 10,300.